In this demonstration, I'll show you how to create a moving assembly from a fixed assembly. Here I have a slider crank mechanism which I've made in SolidWorks already in a fixed assembly which is based on a master sketch. Here you can see in my master sketch, if I open this sketch, you can see that all of the geometry for the slider crank mechanism is already defined. All of the parts are based on this master sketch, so if I change some of this geometry, pull one of the points, and if I change one of these dimensions, say from 0.5 to 0.6 inches, and I exit the sketch, everything already updates and changes automatically in the assembly. Now coming back to what I had originally, now I want to go and make the moving assembly. So I'll go File, New, I'll create an assembly. This dialog box comes up on the left. I'll close that. Now the first thing I'm going to do is tile my windows. So I'll go to the window menu and I'll tile horizontally. Now this new moving assembly, I'll go to File and Save, and I'll call this moving assembly and save. Now the first thing I'll do is, in my fixed assembly, I'll go and I'll select the part that's the base. I'll drag that into the moving assembly, and it comes in as fixed already. Now the next parts I'll move in, so I'll bring in the slider. I'll select the link, I'll select the crank, a pin, and another pin. Now all of the parts are in the moving assembly. So you'll notice in the feature tree here that the base link came in fixed, and all of these other parts are floating. So to constrain these in space, I am going to mate these parts together. So the first one I'll do is I'll mate the slider. I'm going to take the top plane and then the top plane of the base. I'll mate those together. You can go Insert, Mate, or in this case press M on the keyboard. Those two planes are coincident together. I'll press this check mark here. To accept the mate. The next mate I'll put in, I'll select the face on the outside of the slider, and this face here, make those tangent. And I'll do the same thing for the other side. So now the slider is free to slide within the slot in the base. You'll notice that in SolidWorks that the slider is allowed to keep going into the solid part of the base. And that's one of the faults of SOLIDWORKS being a model rather than a physical part. Next, I'll mate the link. So I'll take the hole and the slider, mate those. I don't want them coincident. I want them to be concentric so that they can pivot about each other. I'll accept that. The next one I'll do, I am going to take top plane of the base and the top plane of the slider. Instead of making them coincident, I'm going to make them 0.25 inches apart. Except in this case, I want to flip it, so it's 0.25 inches above the base. I'll accept that. Similarly, I am going to take the top plane of the crank and the top plane of the link, and again make that 0.25 inches. Flip that the other way so it's exactly where I want it. This hole, and this hole, and this. Make sure that's selected. Are all concentric. Now the fat pin needs to be aligned. So the top plane of the fat pin and the top plane of the crank. Whoops. Top plane, and these are going to be coincident. And you see that I've created an error here. Now here you can see the list of errors that tell me what's wrong. And I have too many mates on this part. It's an easy error to do. And what SOLIDWORKS is telling me is I have too many mates and I'm over-defining my product. So I'll close this. I'll go back to the last mate I created. I'll delete this mate, and the warning's gone, everything's fine again. So I'll try to do the same thing again. I'll take the top plane and the top plane, bring those together, and accept it. I'll take this hole, make those concentric, take this pin, make those concentric, accept that, find the small pin in the feature tree, take the top plane of that and the top plane of the base. Align those together. Now you can see that pretty much everything's mated together. If I go back to this view, I can now select the slider. I can move it, and I can pull it back and forth, and you can see this mechanism moves as it should.